Hi everyone, I am going to discuss solving system of linear equations in three variables, this time making use of elimination. Now, last time you learned about solving for system of linear equations in two variables using different methods like graphing, eliminations, substitution and making use of the determinants. So this time we will be working on the solution for system of linear equations in three variables using elimination. So you already have the idea on how to solve for the system using elimination since I was able to introduce this to you as we solve for the solution of system of linear equation in two variables. So let's work on this system. Okay. So as you can see, we have three equations here. We also have three variables. So we're going to solve for the values of x, y, and z. So the solution is composed of an ordered triple x, y, z. So we denote this as our first equation, this as our second equation, this as our third equation. Now we will be setting or selecting two pairs of linear equations among the three equations, and we will eliminate the same variable from each pair of equation that we're going to select. So in the three equations here, we can eliminate y. So we can select the first and the second equation first. So we have x plus y minus 3z equals negative 10. And then x minus y plus 2z equals 3. So here, since the coefficient of y here is the additive inverse of each other, so for us to eliminate that y, we're going to make use of addition. So we have 2x. So this is 0. Now negative 3z plus 2z is negative z. Then this is equal to negative 7. So this will serve class as our equation 4. And then we select equation 2 and equation 3. So we have x minus y plus 2z equals 3. And then 2x plus y minus z equals negative 6. Now, again, we'll make use of addition to eliminate y since the coefficients of both y here are the are the additive inverse of each other. So by addition, we have 3x and this will be cancelled. So we now have plus z here equals negative 3 and we'll consider this as equation 5. Now we're going to make use of equations 4 and 5 and we will eliminate another variable. So we have 2x minus z equals negative 7 and then 3x plus z equals negative 3. Now we will make use of addition to eliminate z. So we have 5x and this is cancelled. We have negative 10 here. So dividing both sides by 5. So we now have the value of x equal to negative 2. Now we will substitute x equals negative 2 to either equation 4 or 5. So if we're going to consider equation 4, so we have 2 times negative 2 minus z equals negative 7. So we have negative 4 minus z equals negative 7. We can transpose negative z on this side and rather negative 7 on this side and then negative z on the other side. So we have negative 4 plus 7 equals z. So negative 4 plus 7 would be the value of z and that is 3. So we now have x equals negative 2, z equals 3. So we will now substitute x equals negative 2, z equals 3 to any among the original three equations. So if we're going to consider equation 1, for example, so we have x plus y minus 3z equals negative 10. So x is negative 2, and then plus y minus 3 times z, which is 3, and then equals negative 10. So we now have, okay, let's place it here. So we'll transpose this negative 2 and this negative 9 on the other side of the equation. So what will remain on the left side is the variable y. And we have negative 10 on the right side. So negative 2, that would mean plus 2. And then minus 9 would mean plus 9 here. So your y is equal to 11 minus 10. So 1. So the solution for this system is negative 2, 1, and 3. So x for negative 2, y is equal to 1, and then 3 equals z. So for number 2, we can eliminate z. So this will be our first equation, second, and then third. So working on the first two equations, so we have 3x plus 2y minus z equals 6, and then negative 2x plus 2y plus z equals 3. So we can make use of addition for us to eliminate z because the coefficients of both z here are the additive inverse of each other. So adding 3x and negative 2x will give us x, and then 2y plus 2y is 4y, and then canceled, and then we have 9. So we will consider this as equation 4. And then we have second and third, negative 2x plus 2y plus z equals 3, and then x plus y plus z equals 4. This time we're going to make use of subtraction since the coefficient of both c here are the same. So take note that we will be changing the sign of all the terms of the subtrahend, and then we will proceed to addition. So this is now negative 3x, and this is now y, and cancelled. So we have negative 1 here. So this is our equation 5. So we're going to make use of equation 4 and 5 to eliminate another variable. Now, if we want to eliminate x, so we have to rename the fourth equation by multiplying each term here by 3 if we want addition, negative 3 if we want subtraction. So renaming the fourth equation by multiplying each term by 3 and rewriting it here. So we have 3 times x, 3x, and then 3 times 4y, we have 12y. 3 times 9 is 36. And then let's copy the fifth equation. We have negative 3x plus y equals negative 1. And then perform addition. So we have 13y equals 35. Again, when we rename the fourth equation and multiply it by 3, we have 3 times x. So we have 3x here, and then 3 times 4y, you have 12y, and 9 times 3 must be 27. So, combining the two equations by addition, so x will be cancelled, and then 12y plus y is 13y, and 27 plus negative 1 gives us 26. So, dividing both sides by 13, we have the value of y equal to 2. Now, we're going to substitute y equals to either equation 4 or 5. So if we're going to use the original equation 4 and substituting y equals to the y of that variable, so we have x plus 4 times 2 equals 9. So this is x equals 9, product of 4 and 2, so we have 8 minus 8. So we have x equals 1. Now, solving for z requires us to substitute x equals 1 and y equals 2 to any among equations 1, 2, or 3. So if we're going to consider, for example, equation 3 and substitute the two known variable here, so we have 1 plus 2 plus z equals 4. Now transposing 1 and 2 on the other side of the equation, we have z equals 4 minus 1 minus 2. So z here equals 1. So the solution for this system is the ordered triple 1, 2, 1. Okay, so let's work on another example. So we'll consider these as equation 1, these as equation 2, and these as our equation 3. Now, in the event class that we come up with three different coefficients of any among the variables, so what we will do is to rename each equation. So we will come up with either the same coefficient of the variable that we are trying to eliminate, or at least additive inverse. Okay, so it's either of the two. So if it does not satisfy either condition, then that's the time that we're going to rename the equation. So we're going to consider the first and second equation, and we will eliminate y. So we have 3x plus 4y plus 2z equals 9, and then 4x minus 4y plus 3z equals 3. And then we will use addition. So 3x plus 4x is 7x. So this is 0. This is plus 5z. And we have equals 12. So we will consider this as equation 4. And then we're going to make it a second and third equation. So we have 4x minus 4y plus 3z equals 3. And then we have 2x minus 4y plus 3z equals 1. Now, since we're trying to eliminate y here because we have eliminated y, so we come up with the fourth equation. So we have to eliminate y also. So we're going to make use of subtraction since the coefficient of both y here are the same. So we have 4x minus 2x. We have 2x. And then this is cancelled. And this is cancelled as well. So we have 4. So right away, we can solve for the value of x. And that is done by dividing both sides by 2. So x is 2. And we will substitute this x equals to equation 4 only. So we have 7 times 2 plus 5z equals 12. So 5z equals 12. So this is 14 transpose on the other side minus 14. So we now have, now let's go back in simplifying this equation. So we have 4x minus 2x. So we have 2x. And then this is 0. This is also 0. But 3 minus 1 is 2. So we can solve for x, and that is done by dividing both sides by 2. So x equals 1 instead of 2 a while ago. And then we will substitute x equals 1 to equation 4 only. So we have 7 times 1 plus 5z equals 12. So 5z here equals 12 minus 7. So 5z equals 5. So dividing both sides by 5, we have z equals 1. Now we will substitute x equals 1 and z equals 1 to any among equations 1, 2, or 3. So if we're going to consider equation 1 and substitute x equals 1 and z equals 1 to the x and z of the first equation, so we have 3 quantity times 1 plus 4y equal rather plus 2 times 1 equals 9. So we have 4y, isolate y on the left side. So we have 9. So 3 times 1 is 3. And transpose on the other side, we have minus 3. 2 times 1 is 2. Transpose on the other side, minus 2. So 4y equals 4. Divide both sides by 4. We have y equals 1. So the solution for the system is represented by an ordered triple: x equals 1, y equals 1, and z equals 1. So I hope you are able to understand how to solve system of linear equations in three variables using elimination. And that's it for now.